Okay, now consider the nomenclature of anionic entity. We already discussed the procedure for the nomenclature of cationic and neutral. There is a small difference in the case of anionic entity. Let me show that the difference. Listen. If the molecule is K4 FeCN 6 times, okay, K4 FeCN 6 times, okay, this is a coordination compound with anionic entity, right? Because the counter ions are cation, okay. So what you have to write the first means, you simply look from the left to the right. So what do you see first? You can see the counter ion first. So simply write the name of counter ion. Write the name of counter ion. Okay. The counter ion is potassium. Now you need to mention the number of counter ion. Okay. So this is potassium. Potassium. No need of number. Ready. Potassium. The next. After the counter ion, you can enter to the entity. Okay. Potassium. Hexa. Once you enter to the entity, you can name the ligand. Here the ligand is cyano. So hexa, cyano or cyanato. That's up to you. Okay. Hexa cyano or cyanato, followed by the central metal. Here the central metal is iron. Okay. But you have to write here as ferrate. Ferrate. Write here as ferrate. Okay, ferrate. And what about the stock valency? Here the charge of counter ion potassium is +4. So the entity have a charge of -4. Ready? Entity have a charge of -4. Was 6 cyanide offer -6. Since here is a -6, to bring a -4 in the outside, this should be +2. So iron is in +2, but they usually mentioned as ferrate 2. Ferrate 2. Okay? Ferrate 2. Ready? Fine. Which means there is a difference in that. I'll explain that. Listen. If anionic entity named, then central metal end with the 8 suffix. Central metal is end with the 8 suffix. Okay? Ready? For example, another example, if I have AgCN twice minus. AgCN twice minus. -2 + 1 -1 5. AgCN twice minus. So this is an anionic entity because the the entity have a negative charge. So you simply enter to the entity, and now you can name the ligands. The ligand are cyanide. How much cyanide? Di. So this is dicyano. Okay. The name of Ag here with the 8 suffix, it has argentate. Dicyano argentate. What about the oxidation state? The Hall charge is -1. But the cyanide have -2 since it is 2. So your silver should offer +1. And this is a kind of negatively charged ion. So dicyano argentate 1 ion. Okay. So here the suffix is not silver. It is argentate. The suffix is argentate. It is not your silver. Ready? So I think you okay with that difference. Ready? You're okay with that difference. Okay. So I'll give you some names of central metal when they are mentioned in a anionic entity. Okay. Example means, wait, listen. If you have aluminum, then it is named as aluminate. Aluminate. Okay. If you have zinc, then named as zincate. If you have copper, named as cuprate. If you have iron, ferrate. If you have nickel, the central atom nickel, nickelate. Or if you have palladium, then it is palladate. Or if you have platinum, then it is platinate. Okay. If you have platinum, nickel, platinum, gold, orate, mercury, mercurate. The usual cobalt, cobaltate, chromium, chromate. Okay, etc. These are the different types of names of your central metal if it is in a anionic form. Ready? If they are existing in an anionic entity. Listen, let me give you one more example. K3, Al, OX, thrice. So this is a cationic entity, right? No doubt. Your counter ion is, sorry, this is an anionic entity. Your counter ion is cation. That's potassium. So the name potassium. So once the counter ion named, you enter to the entity. Where the entity, the ligand is OX. OX means oxalate. OX means what? Oxalato. Oxalato, trioxalato is enough because oxalato is a didentate ligand, right? But there is no what? There is no multiplying prefix like ethylene diamine. We know in ethylene diamine there is a di, but in oxalato it's a simple name. Okay, so trioxalato is enough. Potassium trioxalato, aluminate. It's not aluminium, aluminate, because this is a anionic entity. So 3 potassium have +3 charge, so the entity should be -3. And you know the charge of one oxalato is -2, so this is -2 into 3, so -6. Since the entity or the coordination sphere with ligands of -6 charge and the whole charge is -3, your aluminum should offer +3. And you all know that aluminum can offer only +3. Okay, so this is the name, right? Fine. Okay. So this is how you can name the anionic entity. Okay. So let's do some examples. Ready? Some examples for nomenclature. So we know the basic idea of nomenclature. So we can do some examples. Then only it become more practiced. Okay. So I'll give you questions and you can write the names. We will discuss that. Okay. So first one. CO NH3 6 times Cl3. The second one, FeCO 5 times. The third one, CuGly twice. Next one, NiDMG twice. Either the DMG is in a small version or capital version, whatever it may be, no problem. Okay. The next one, CO OH2 6 times 2 plus. The next one, Zn NH3 4 times 2 plus. Next one, PT En twice all of 2 plus. Next one, Ni En thrice all of 2 plus. Ni En thrice all of 2 plus. Okay. Next one, PT Cl2 NH3 twice all of Cl2 or the 10th one. Cu NH3 4 times OH2 twice all of Cl2. Okay, ready. So this much is enough in the first section. So we can name the category. Okay, what about the first one? In the first one, the counterion is anion. So the entity is cation. Okay, so you named from the entity itself. Okay, so when you enter to the entity, you can see the ligand. Okay, you can see the ligands. Ligands, what are the ligands? Amine. How much amines? 6 amines. Okay, so the name is 6 amines. So hexamine. And the anionic cationic entity, so cobalt it is not needed, cobalt is enough. And the charge, this is -3, so this of +3, so this is 0, so that +3 is offered by the cobalt. So cobalt. And the final is chloride. Now in of number of your counterion, simply chloride is enough. The next, the Hall charge is 0, right? Because there is no special charge mentioned, means the Hall charge is 0. Since the Hall charge is 0, that belongs to a neutral compound. In the case of a neutral compound, the name is, first of all, you say the ligand. Ligand is carbon monoxide. It is said to be carbonyl. So this is pentacarbonyl. Pentacarbonyl. But this is a neutral ligand, so iron is enough. Pentacarbonyl iron. Pentacarbonyl iron. Well, the oxidation state is 0 because the Hall charge is 0. Carbon monoxide is also have 0 charge. So the iron is in 0 oxidation state. Pentacarbonyl ion 0. Okay. The next, the Hall charge is given as 0. And glycimato. I'm sorry. Dimethyl glycimato. This is glycinate. Glycinate, the charge is -1. So -1 into 2, -2. So your copper should have offer +2. Okay. So this is simply glycinate. So di is enough. Diglycinato. Copper is needed because a neutral entity. Copper which is in 2 oxidation state. Okay. So here the Hall charge is again 0. Ready? DMG, the dimethyl glycimate, have a charge of -1. So the total charge -2. So the nickel should have after +2. So this is also a neutral ligand. Dimethyl glycimate. So there is a di, right? So you should use bis dimethyl glycimato. Bis dimethyl glycimato. Okay. Bis is for the multiplying prefix of 2 dimethyl glycimato, followed by nickel. Nickel is enough, neutral. Charge of nickel is 2. Okay. The next is also cationic entity. Cationic entity means the ligand is water. OH2 means H2. So how much water? 6 water. So that's hexa aqua. The Hall charge is +2. Water have a charge of 0. So cobalt have a charge of +2. Hexa aqua, cobalt 2 ion. Cobalt 2 ion. The next is also cationic complex where the ligand is amine. So that is tetraamine. Zinc is enough. Cationic complex. The Hall charge is +2. This having 0 charge. So the +2 is offered by zinc. So the zinc is in 2 oxidation state. Okay. Next is also cationic ligand, cationic entity, but the ligand is bidentate ligand, ethylene diamine. So where there are 2 ethylene diamine. So bis ethylene diamine. Now platinum is enough. Now the charge +2. En have 0 charge, so this have +2 charge. En ethylene diamine is a neutral ligand, so charge is 0. So this one have +2 charge. So 2 ion. Okay. Now again same kind of one. The charge is +2. Here 0. So here it is +2. Okay. So that is tris, ethylene diamine, nickel 2. Nickel is in 2 oxidation state. Okay. The next, chlorine have -2, so entirety have +2, or amine have 0. Okay. For these 2 chlorines have 0, so the platinum is in 0, I think. So what about the name? Ligand, chlorine is named first. Sorry, amine is named first. Diamine, dichlorido. Diamine, dichlorido. Platinum 0. Platinum is in 0 oxidation state, right? Chloride. Platinum 0, chloride. What about the next? The Hall charge is -2. Here is 0. Here is 0. Water is 0. Water have 0. This is also 0. So the +2 offered by 3. Sorry, this is not 0. Hall charge is counter ion have a charge of -2. So this will be +2. So what about the name? Amine aqua. AM AQ. AM named as first. So tetramine, diaqua, copper 2 chloride. Okay. Okay. Let me write the questions. The questions are CO NH3 5 times. CO NH3 5 times ONO Cl2. ONO Cl2. Okay. Sorry, the Cl2 is here. 11th one, 12th one, Ag NH3 twice Cl. 13th one, K2AgCl2, I'm sorry, KAgCl2, BaCuCl4, Cu2, FeCN 6 times, AuCN 4 times, 2 minus. COBr4, 2 minus. HgI4, 2 minus. NiCN4, 2 minus. FeC2O4 thrice, whole of 3 minus. 21. Okay, 20 is enough. And the next is a special category. We'll discuss that. Listen. What about the names of this much also? So here the most of them are anionic entity, right? Most of them belongs to anionic complex. So first one, that's a cationic one. First and second is cationic because counter ion is anion. So here 2 chlorine -2. ONO means nitrito O having a charge of -1. 2 chlorine -2 means the entity should have up to entity have to offer +2. But here the ONO ligand have -1. Here it is 0. So here already -1. To bring the +2 on the outside, this will be +3. So named as amine nitrito. So that's pentamine. Pentamine Nitrito O is the category, right? Nitrito O, that's simply cobalt 3 chloride. Okay, here the counter ion is also anion -1, the entity have +1, this is 0, so silver is in +1. So diamine silver 1 chloride. Diamine silver 1 chloride. Okay, here the entity is anionic. From this example onwards, the molecules are anionic. So, counter ion cation entity anion -1. So this is +1, this is -1, both the chlorine of -2. So here already -2. To bring -1 on the outside, silver will be in +1. So the name is, first of all, your counter ion. Potassium. Then the ligand in the entity dichloride of, it's not silver, that's argentate. Here it is silver because cationic entity silver, anionic entity argentate. Argentate 1 is the case. Okay. Here barium is the counter ion. Barium have to offer, barium second group element always +2. So this will be -2. But the 4 chlorines -4. So this one should be +2. Okay. Then only you obtain the -2. So this is a barium. First of all, the counter ion barium. Then the ligand tetrachlorido. Barium tetrachlorido. It's not copper. It's cuprate 2. The next FeCN 6 times. Okay. Counter ion copper. We don't know the charge of Cu2 plus, and we know wait, check me whether that is copper or calcium. Okay, this is copper. But the oxidation state is +1. Okay, copper can show +1 or -2. Okay, so here it is in the question. It mentioned as +1, so +1 into 2. So here will be +2. So this is -2. Okay, there are two possibilities for the entity FeCN 6 times. FeCN 6 times have two possibilities. Either the FeCN 6 times have a 2- charge, or the FeCN 6 times have a 3- charge. These are the case. I'm sorry. Either it is 2- or it is 4-. Then only, either it is 3- or it is 4-. If it is 3-, then iron is in +3. Okay, acceptable oxidation state of iron. If it is 4-, iron is in +2. That's also acceptable. So it is clear that these all copper are in +2. So the charge, 2 coppers are in +2. So the charge of this one +4. Because here either -4 or -3. Okay. So using these 2 copper, it is clear that they're always +4. Then only the entity -4. So here -6, iron +2. Okay. So copper is enough. Ready. So it is better to show the oxidation state of copper also, because copper having variable form. Copper 2, the next hexacyano, ferrate 2. Ferrate 2, yeah, ferrate 2. Copper is a variable transition element to variable oxidation state, so you have to mention its oxidation state also. That's better. Okay. The next belongs to gold, a molecule with the gold. So whole charge is -2, cyanide have -4, so this should be +2. So tetracyano. It's not gold, it is orate. Orate 2. And this one. All charge -2, bromine half -4, cobalt should be +2. Tetrabromido, bromine with a ligand name bromido, cobaltate 2. All charge -2, this half -4 because iodine is in -1. So your mercury should be +2. Tetraiodido, iodido, mercurate. It's not mercury, mercurate 2. All charge -2, here it is -4, so this should be +2. Tetracyano, nickelate. Since it is an anionic entity, nickelate. Nickelate 2 is the category. All charge -3. This is C2O4. C2O4 means COO, COO, oxalate. Oxalato otherwise said to be C2O4. So oxalato have a charge of -2, so -2 into 3, -6 is the charge offered by ligand. Where the outside charge is +3, so this should be -3, and thus the ion should be +3. So this is oxalato. Tri is enough. Trioxalato, ferrate 3. Hope you okay that. Okay. Now we have one more category said to be. Here, either the counter ion is a simple ion. Okay. In case of anionic entity, the counter ions are cation. It is a simple ion. In case of cationic entity, the counter ions are anions. That's also simple ion. Now we have some kind of molecules where the both are entities. Cationic and anionic portions are complex parents. Okay. Then let us do. Let's check how they can be named. I'll give you a special category. Both cation and anion are complex. The category where both cation and anion are complex. Okay, fine. So I'll give you some examples. The first one, Cr NH3 6 times all of CO Cn 6 times. Okay. Next, Pt NH3 4 times all of Cu Cl4. The next, Cr NH3 6 times CO, no need of that. Pt Py 4 times all of Pt Cl4. One more, Pt Cl2 NH3 twice all of Pt Cl4. Okay, so in this case, in this kind of molecule, listen carefully. You should know, usually the cationic complex are expressed in the left side and anionic are in the right side. This is a cationic part, anionic part. Cationic part, anionic part. Cationic part, anionic part, but both are entities. Okay. You should know at least what is the coordination number. If the coordination number of the central atom, which mentioned the left side, is this much, then their relative oxidation state is this much. Okay, which means if the coordination number of your amine, which represent the first, which means that if the coordination number of the entity, cationic entity is 6, and the central atom is chromium, then its oxidation state will be +3. That idea you have to know. If the coordination number of the central atom is 6, or the central atom, if the coordination number of the cationic entity is 6, but the central atom is chromium, then the oxidation number is generally +3. So +3, and this is the so chromium have +3 charge. So these all amines have 0 charge. So the entity will be +3. If this entity have +3, so here will be -3. If this have -3, your cyanide of a -6, then your cobalt will be +3. So you should know the whole cases, okay? So this is named as hexacyano. First, you enter to the cationic entity, hexacyano chromium 3. Now the cationic entity is over. Now get into the anionic entity. I'm sorry, this is not cyano. This is amine. Here is the cyano. Hexacyano cobalt 3. I'm sorry, this is anionic entity, cobaltate 3. The next, if the coordination number of platinum, palladium, nickel all are 2, then usually, or at least you have to know, if the cationic complex with a coordination number of nickel, platinum, palladium, etc. with 4, then their charge will be +2. So this should be in +2. So here 0, this will be my +2. So this entity should have to offer -2. So chlorine 4 -4, your copper will be in +2. So now the name is tetramine. Platinum 2. Tetrachlorido. Cuprate 2. Okay, tetrachlorido cuprate 2. Ready. The next, here also pyridine monodendrite ligand, coordination number 4. So platinum is in +2. Pyridine 0, this is 0. So this is -2, chlorine -4, this is +2. Okay. So this is pyridine, tetrapyridine, platinum 2, tetrachloro, chloro or chlorido, platinate, anionic entity, platinate 2. Here also the coordination number of cationic platinum entity is 4. So this is +2. Here already -2. Okay. And this is 0. This is the whole charge is 0. If the whole charge is 0, this one also have all charge 0, but the 4 chlorine have -4. So your this platinum will be +4. Okay. Hope you understood. Even though its coordination number is 4, this platinum have +4 charge. So you should know that if the first entity where the central atom is cobalt chromium, or the coordination number is 6, then its charge will be +3. If the coordination number is 4, then its charge will be, in case of cobalt and chromium, the charge will be +2. Okay. Like that, if it is silver or gold, coordination number is 2, then the charge will be +1. If it is copper, coordination number 4, charge +2, coordination number 6, charge +4. If it is platinum, nickel, palladium, coordination number 4, charge +2, coordination number 4, 6, charge +3. Okay. So keep that points and you are not. So the first entity, the platinum is a central atom, coordination number 4. So the charge we can assume that +2. And using that data, we can analyze the charge of other. Even though there is coordination number 4, but the charge is +4. That depends, because it is clear that this is 0. So this is 0 means this arrangement will be like this. Okay, fine. So what about the name? Diamine, dichloro, platinum 2, tetrachlorido. This is dichlorido, okay. Tetrachlorido, chloro or chlorido, both are okay. Chlorido is a ligand name which is modified. Initially they are mentioned it as chloro. Later the modification used the name chlorido. Tetrachlorido, platinate 4. So I repeat you that. If both are complex, then you should know idea. that if the coordination number is given, then the charge of the oxidation state of the central atom of cationic complex. Okay, then only you can name this. Ready? Fine. So that's all about the nomenclature. Now I can discuss the theories of coordination compounds.